Good morning, everybody. I'm Ryan Burgoyne, and today I'm going to be talking about using the Metaio SDK to create amazing augmented reality experiences. I'm going to start off by discussing a bit about Metaio as a company, and then I'll describe the range of products that we offer and what their differences and similarities are. And then I'll give you a couple of examples of creating augmented reality experiences, both using our drag and drop creator environment, as well as using native code for Android, which will support, and both of these will support wearable devices. Because that's what I'm most excited about, is this ability to wear glasses and without any camera feed, see the world in front of you and the augmented reality overlaid on top of it as if the objects were real. And so I'll be talking a little bit about that. So Metaio is the augmented reality company. For the last 12 years, this has been our core competency. Our passion is developing computer vision algorithms and augmented reality technology to create these kind of applications. We're constantly doing research and development into new technologies. For example, you may have heard recently in the news, we announced thermal touch as a new technology that we're developing. And you'll be able to try that out at the Expo tomorrow. And using these technologies, we create a variety of different software. And those include the Metaio Creator, which is a type of drag and drop environment that also allows for further customization using code, and also the Metaio SDK, which supports a variety of mobile and desktop platforms. And also we offer Metaio Cloud, which lets you store augmented reality applications in the cloud so that you can update your files in the cloud and have that pushed to the user's devices without them having to update their applications. Part of the strength of our platform is the developer support that we have. So on our Metaio developer portal at dev.metaio.com, you have access to over 50 webinars, as well as elaborate tutorials, all these code samples, and our Metaio help desk has Metaio developers as well as community members answering questions. So if you have questions about how to get started with Metaio development, this is a great resource. And also, if you've done Metaio development before but you have questions about how to proceed, this is a great benefit. So I wanted to talk about, we offer a lot of different products, and I wanted to help clarify about what the differences are. And I think the best way to start is to start with Metaio Creator and show you an example of building an AR experience with Metaio Creator. So I'm going to go ahead and open that up here. This is the latest version of Metaio Creator released today, version 3.5. And creating a new augmented reality experience is really simple. So once I've created a new project, I can go down here and add a new trackable. And in this case, I can choose from a lot of different tracking technologies. You can see image tracking here. There's extended image tracking, which starts with an image, and then as you move away from the image, even if the image is not in the field of view of your camera anymore, SLAM will be used to create a dynamic 3D point cloud and continue tracking successfully. And then if you've already created a point cloud of the object you want to track, you can do 3D tracking in that way, or you could track larger environments. And then a new beta in our SDK is the ability to track faces as well. So in this case, I'm going to do image tracking. And I'm going to go ahead and open up an image here on my desktop. So this image of a space nebula is added, and I'm going to add a 3D model to it. So we can use some simple controls here to rearrange this model how we like, so that it will display properly for our scenario. Okay, and when we're happy with that, we can customize its properties. So I'm going to go here and add some animation. an idle animation that loops once it's displayed. Okay, so when I'm happy with this, I can go ahead and click Quick Preview, and it will open up this preview window. And as I hold up the target, you can see the spaceship there augmented on the target, and with the animation being played. So this is a pretty standard type of AR scenario. But I wanted to describe, and I'll come back to it and add some when I'm talking about wearables. But for now, I just wanted to talk about the ways this augmented reality content can be used. Up here in the export menu, you can do a couple of different things. You can create an app, and so you can create a cloud app. And now what a cloud app is that this project that we just created is the programming language behind it is JavaScript. And that JavaScript and HTML, it can be exported and uploaded to the cloud, and then a native application on Android or iOS can download those HTML and JavaScript files and display them to the user. The benefit of that is that the provider of the application, whenever they want to update the content of the application, they're able to make changes, upload the content to the cloud, and it will be immediately pushed out to all of the users without the users having to download a new version of the application. Additionally, the developer can create one application that runs across multiple platforms, including Android and iOS. But another option is you can create an SDK app which runs directly, which will install the JavaScript and the HTML directly into the application package, so it's not connected to the cloud if you don't want to worry about hosting those files with Metaio or on your own server. And then you can also export as a desktop app. Another option is to use the Junaio browser. Metaio creates a special augmented reality browser called Junaio, which does the same thing as the cloud apps, except that it provides a single interface to access a variety of different portals. So I can create a channel here for this application and upload it to Metaio's cloud or to my own web server, and then a user who is using Junaio can navigate to my channel and download the content, and they'll be able to experience this augmented reality application. So that's what you see here in this slide is a description of the various types of applications that can be created with Metaio's products. So you can have a Junaio channel, you can have your own cloud app, which is basically a Junaio browser baked into your own application, your own branded application that's accessing your Junaio channel. Or you can have an SDK app where the JavaScript and HTML are inside of the application package. We also support Unity applications. Now, one other method, if you don't want to use Metaio Creator and you want to have access to more of the device-specific functionalities, for example, if you want to use Android's speech recognition features, you can create your application directly for Android instead of using the JavaScript and HTML bridge. Or you can code for Windows or iOS. And so these platform-specific development interfaces provide you greater flexibility. And all of the different types of applications and all of these different APIs tie into the same core Metaio SDK, which is optimized for the various hardware platforms that we support, including iOS, Android, Windows, and macOS for the creator. So Metaio provides all of these different layers from AR-specific hardware in our AR engine. We provide development software in the form of our SDK and creator. We provide delivery for AR content through our own Metaio cloud servers, and also we provide the Junaio AR browser for users to access your applications. So this is a bit more detail about how the JavaScript and HTML augmented reality experience works. We call it RL, which is the augmented reality experience language. So the Metaio SDK on the device is doing the actual 3D rendering, the tracking, all of the camera capturing and drawing. And then with your HTML5, you're able to draw a graphical user interface. And in the middle, you have this JavaScript bridge, which is a special API that communicates with the Metaio SDK and gives commands to perform the tracking logic. And you can also provide a static XML file which will define the models that you're going to be using and the tracking configurations. So that was a little bit about Metaio Cloud and about RRAL. Now I want to talk about some of the other features of the SDK. Specifically, we support a variety of popular 3D formats, including OBJ, MD2, and FBX. And we also support some really neat advanced rendering features. So this is one that it currently works in our SDK, that you can have a depth of field effect. As you'll see in this video, when you have a virtual object next to a real object, it's easy to tell which is the real and which one's virtual, because as the real object gets close to the camera, that part of it becomes blurry because of the depth of field. Now, with the feature in the SDK of adjusting the depth of field, you can see that the 3D model's focus is blurred in the same way as the real object to blend it even more in with reality. So the Metaio SDK provides a lot of these advanced rendering features to make the experience for users even more immersive, including motion blur, and we also support custom shaders so you can create your own advanced features and dynamic lighting. So what kind of contents can you include in the SDK projects? You can create a variety of different kinds of geometries. You can create billboards, which are basically 2D graphics that have a position in the 3D world and are always facing the user. So those could be text or images. And then other 2D geometries include videos and images. And then we have 3D geometries, such as 3D models and 360-degree views. And then the radar, that refers to when you're doing a geo AR experience and you want to show the locations of points of interest. The Metaio SDK provides a large variety of tracking technologies. When you're doing augmented reality, most of the time, your goal is to find out where the world is, where you are in relation to the world, so that you can properly draw the augmented content on top of your view of the world in the right place. And you need to know your location relative to the world in order to do that. So we combine a lot of different methods to get that information. So from the basics of ID markers and picture markers, LLA markers encode geolocation information in the marker itself. Then we support QR and barcode reading. And then static sensors that exist in mobile devices like GPS and orientation sensors can be used. And they can also be fused with other sensors to get more accuracy. Maybe the most commonly used features are these markerless tracking features, where we can do 2D markerless tracking, which tracks a standard image, but we've added the ability to extend that 2D image tracking. So once you move away from the area where the image is in view, you can continue tracking by recognizing 3D feature points in the world. And you can also assign create a 3D map of a known object and assign augmented reality content to be mapped onto that. One of the new features that was released recently that I'll be talking about in a minute is 3D edge-based tracking, which can be used in situations where lighting or other conditions aren't ideal to do SLAM or other 3D tracking. And then in this latest release of the SDK, we've released a beta of our face tracking. All of these markerless tracking methods can also be done in instant or SLAM mode, where you take a picture or create a map of the environment on the fly, so that even though you don't have a pre-prepared marker, you're able to still create the tracking configuration that you need. So this is the edge-based tracking that I was talking about. As we were developing this application for Volkswagen, we recognized that it was very difficult to track a car because of how reflective the surface was, and some of the other situations that make it difficult to recognize the car was the lighting conditions changing, or if there just wasn't much texture, like the side of a car, it doesn't have a lot of variety in gradient or color. Also, if the car gets dirty, suddenly the texture has changed. So texture-based tracking of this object which proved to be a real challenge. So the solution that we came up with for this example was to do edge-based tracking, where we recognize the edges of the car features and then create a CAD model that embodies those edges and use that to track. So I'll show you a video of that in action. So this first part just has the user selecting the options they want. So now you can see they see an edge map, and as soon as they hold it over the car, it snaps into place. And that part of the car is augmented with the features that they're looking for. So this edge-based tracking is very robust as it's moved around, and it's a great feature of our SDK. Another new feature that is currently in development is using depth cameras to handle occlusion. One of the issues that you have when you put augmented content over a video feed of the real world is that a lot of times objects that should really be behind the augmented content look like they're in front of it. And so using new depth cameras, we're able to determine what objects really are, how far away the objects are in the image, and in real time create the proper occlusion effect. So I'll show you that video here. So as you can see, this chair has been added to the scene, but the table leg and the rest of the scene are still occluding the model of the chair, even though the chair is the augmented content. And so using the depth camera, we're able to, in real time, reconstruct the scene and properly create occlusion to give you give the illusion that the chair is really sitting there. One of the other, so those were the tracking features of our SDK, and one of the other neat benefits of using our SDK is our continuous visual search technology. Some applications of augmented reality rely on a large database of images. For example, posters or movie cases that you want to recognize and provide content for. And our continuous visual search technology relies on our cloud infrastructure to access in real time a database of images and respond over the network with the proper information. So you can see in this example, different movie titles are put in front of the camera and almost instantly recognized by the software. This continuous visual search can support up to 1 million different objects and recognize them, each individually. And the way that this works is we have the CVS service, which is hosted on the Metaio servers, and there's a query interface which the Metaio SDK uses to send images to and receive responses from in real time. And then when you want to upload data or manage the images that you have in the CVS service on Metaio, you can either use curl or a PHP tool that we've released or Metaio Creator to manage the content that you have stored there. Then in that database, you can have up to 1 million items. These can be images or 3D point clouds, and as well as metadata. And that content can be managed by you and presented to the users of your application. Okay, now I want to talk about wearables, because that's the space that I'm most excited about. So we do support, at this point, we do support the Epson BT200 glasses, as well as Google Glass. And so these features were added recently to the SDK, this ability to do see-through rendering, stereo rendering, and see-through calibration. And so I want to give a little bit of background about why these are necessary for stereo glasses and why we would even want stereo glasses. So if one of the goals of augmented reality is to connect the real world with the digital world, we need to present digital information in a way that it really seems to be there in the real world in front of you. And if it's on a flat 2D screen in front of you, it doesn't really seem like it's there. For the ultimate augmented reality, you need to see it in 3D and perceive it as a real object. Now, the human brain uses many different ways of determining depth. One of the most common ways that we talk about is stereopsis, where your left eye and your right eye perceive a slightly different image of the world in front of you, and from that you're able to discern how far away objects are. And because of that, when we present two different images of an object to the left and right eyes of a user, the user perceives the object of being at a location in the real world. So this is a first step to creating these kinds of experiences. There's other depth cues that our minds use as well, but this is an important first step. So, how do devices like the Epson Movera BT200, how do they render these 3D graphics? Well, what we see is that most of these devices, when you draw to the screen, instead of drawing one picture to the screen, you draw two pictures to the screen. You draw one picture to the left half of the screen, one picture to the right half of the screen. And when the device is put into 3D mode, the left half is moved to the left eye, the right half is moved to the right eye. And if it's done correctly, the user's brain automatically melds those images together to create a 3D image. And so that's our goal, is to make that seamless and like real. So I'm going to show you an example of how that can be done simply in Creator with the example we used before. Because this is the simplest example. And so I'm going to come in here and edit the properties of this model, and I'm going to create a custom script. So here I can create code that will be run when the scene is displayed. So all these API calls are available on our developer portal, dev.metaio.com. And so I'm going to say arel.scene.set stereo rendering true. And then so what that's going to do, I'll show you, is it will show two different images instead of one on the left and right sides of the screen. Okay, so now what you can see is that there's two slightly different images. The camera image is the same because we only have one camera, but the 3D model is slightly different on the left and right sides. But when you're wearing glasses, you don't want to see the camera image because you already see the real world in front of you. There's no need to see the camera image. You already see the real world through the glasses. So the next step to create a good wearable experience is that we need to set to see-through mode. So I'm going to say set see-through true. And then additionally, I'm going to set the see-through color. Now, an interesting thing about projectors, which is how the Epson glasses work, is that when you project a black color, you really don't see anything. So because light isn't black. So if you set the pixels to black, you can see right through them. So that's what we're going to do here, is we're going to do RL scene set see-through color. And then this color is represented by a four-dimensional vector that the components of it are red, green, blue, and alpha, which is the opacity. So we want it to be completely opaquely black. So once I've set that, should be able to run it again. And we see nothing, which is what we want, until we hold up the image and you can see it kind of floating there. Unfortunately, it's very difficult to show you what it looks like through the glasses because you have to be wearing the glasses. So make sure to come on by either Epson's or our booth to take a look tomorrow. But this is how easy it is to create a wearable experience, a stereo wearable experience using the Metaio Creator. Now, for me, besides just seeing objects in 3D, I want to be able to reach out and interact with them. That I think is another critical part of having an effective augmented reality experience. So I wanted to give you an example of how the Metaio SDK lets you dig a little deeper when you use native development on Android in this example. I chose Android because that's the platform that the Epson glasses use. So I'm just going to walk you through the steps of creating a new project using the Metaio SDK for Android, and then what steps we could do to create a simple application that allows you to give 3D input as well as receive stereo 3D output. So when you open up, in this case I'm using ADT, which is Eclipse, which has been customized for Android. I'm going to go ahead and import existing Android code into the workspace. I've already imported the Metaio SDK project you can see here, but I additionally want to import the template project. So I'm going to browse to, I've downloaded the Metaio SDK from our website, and so I put it here in my home directory under lib. And so here's the Metaio SDK, here's the Android folder, and the examples folder. So I'm going to import this template example, and I'm going to copy the project because I want to leave the original one untouched so I can import it again later. So here's the template, and right away it's going to break because I need to tell it where the Metaio SDK is. So as I go into Properties and Android, the Metaio SDK isn't right next to it, so I'm going to remove that and add the real location of the project there. And from then it will work and build, and I could run this application on my Android device, and it would show the example content, which in this case it works with a picture of the Earth and shows you a model of the Earth that will open up and show you the core and the mantle and the different components of the Earth. But I'm not interested in doing that. I wanted to talk about space. So instead, I went and just renamed all of everywhere it said SDK template, I renamed to spacecraft nav. Okay, and so this is what the second step of the project would be. After I did all the renaming and I took out the models of the Earth and took out unnecessary code for what I was working on, and I get this activity. And so I'm going to walk you through a little bit what you're seeing here. So this class extends the AR view activity, and it provides methods for creating, on create, on destroy, and down here you can see methods that are called events that are triggered for when a geometry is touched, or when the SDK is ready, when a movie ends. All these different methods are events that you can respond to. So I did, and I'll show you the code that we added. There's pretty much two parts to creating an effective augmented reality app in the native SDK. First of all, you need to create the source code. So that's what I did here in spaceship.java. And I'll show you the important parts here. First of all, we had to load the content. So we loaded a tracking configuration file. So that tracking configuration file specifies the markers that we're going to use and how they're going to be configured. So in this case, I told you I wanted to have 3D input and 3D output. So the way that I decided to use to do 3D input was I have my platform where the application takes place, and then this is my 3D input device. And it's another marker that can be tracked at the same time as the original platform to move around the 3D model. So as you can see here, this is just an XML configuration file, and it identifies a sensor, the feature tracking sensor, and then it identifies two different coordinate systems. That's what COS stands for, coordinate systems. There's patch 1 and patch 2. So we have the space marker small, that's this image, and then we have the pointer, that's this image. So it's very straightforward. We have the documents on our developer portal how to create these tracking configurations to be as customized as you want. So once I'd created this tracking configuration, I load it, and all this code was taken straight from the template. So you just have to, I just modified the file names, for example, of, instead of, when I loaded the model, instead of earth.zip, I switched it out for a different model, spaceship.zip. But now I want to talk about a couple of things I added to make it interactive. First of all, I wanted to support stereo rendering. So I implemented this method on touch, which will respond whenever someone touches the screen. And if I check if it was an action of touching down, and if it was, then I set the stereo rendering to the opposite of what it was before, and set the see-through to the opposite of what it was before. So that way, by touching the screen, I can switch back and forth between stereo rendering mode and regular mode so you can see the difference. Then here, this on-draw frame method happens every time a frame is drawn. So it happens continually. This is going to be called every time there's a new frame. So this is a really important one. And what I wanted to do is move the spaceship around relative to my second target. And so I was able to use this function, get coordinate system relation between the coordinate systems 1 and 2 that I created in that tracking configuration, and it's returned in this pointer pose. And then I was able to set the spaceship translation to the inverse translation of that pointer pose, and the spaceship rotation to the inverse rotation of that pointer pose. And so the effect is that as I move the input device around, the spaceship moves with it. And so I'll show you a video of this final application. So as you can see, there's three-dimensional input as well as the ability to do three-dimensional stereo output. I didn't show that here because, again, it would have just been a black background, so it's easier to see when you have the camera feed. But when you're wearing the glasses, you can see the 3D model is actually sitting there on the marker. And so as these technologies continue to develop and we refine the way we do these, as we refine the calibration for the see-through on these wearable glasses, it will become more and more that the augmented reality experiences are actually integrated into the real world around us. Finally, the Metaio SDK is free to use with a watermark. Creating and publishing as many AR apps as you want with the Metaio watermark is always free. And so we encourage you to try it out and to get started developing for wearable devices. And this fall in Munich, we want to invite you to visit Inside AR, and also Ismar is going to be in Munich this year. So thank you. Do you have any questions? Oh, we should probably wait for the microphone.
I had a question. Great presentation, thanks. Do you support other animation, path-based animation or anything that you could use to do some of the motion?
So the question was, do we support any path-based animation to do some of the motion? So yes, we support, like you saw that idle animation that I added to the model. Any animation that is baked into a 3D model can be played back in our renderer as well.
Yes. I'm just wondering, is dynamic lighting coming to Creator at all, or is this still mostly you have to bake the lights into the models?
So the question was, is dynamic lighting coming to Creator, or does it still need to be baked into the models? As far as I know at this point with Creator, the lighting still needs to be baked in. But it is supported in the SDK that you can create your own dynamic lighting.
Hi, two quick questions. One, can you speak about typical latency on different devices? And second, what is the plans for support for other Linux distributions?
Okay, so the question was, can I talk about latency for different devices, and what's the plans for support for other Linux distributions? As far as latency goes, when you're doing the video see-through augmented reality, it's not as noticeable when you have latency because the camera frame also has latency, and the augmented content's latency is hardly noticeable in comparison. But when you do the visual see-through, where it's actually a see-through display, the latency becomes much more apparent. So that's something we're working on. But as far as actual milliseconds for different devices, I don't have that right now. And for Linux support, I don't have anything to announce right now.
Hello. I'm interested in the chair in the office thing. What hardware did you use to film that? And what software did you implement to do the image segmentation? And
Great question. So his question was for the RGB-D active reconstruction where the chair was placed in the office with proper occlusion, what hardware and software were we using? We were using a infrared time-of-flight depth camera, and the software was custom reconstruction software developed by our research lab in Munich.
Thank you for the presentation. One question, we already use Metaio and edge-based tracking, but at the moment it's really a big problem for us tracking, for example, dark objects like a black car. Do you see a solution for this with the upcoming SDKs?
So the question was, currently using edge-based tracking on dark objects is a challenge. And unfortunately that is a challenge of the nature of it. Edges are dark, and when you have a dark object, it's difficult to detect the edges. So at this point, using existing visual technologies, we don't have any solution for that.
Hi, I was wondering, I know the gentleman was speaking about animation before, but are there any SDKs that you already have that we can use or that will be coming where you can create 3D books, animation where the characters pop out of the books and run around, or advertisements that pop out of magazines with cars going down a racetrack or something for advertising?
So the great question she asked, do we have any, if I understand right, do we have any SDKs available that would let you create 3D books or 3D advertisements where a character would pop out of the book or advertisement and be animated? And absolutely, that's perfectly doable in the software that I've talked about today. In Creator, you could, as long as you have a trackable image in the book or the advertisement, you can create a 3D animated model that has the animation you want, and it will appear in the location you specify in Creator or in the SDK. So that's absolutely doable.
Hi, I was wondering if, or how well Metaio can track words on a paper.
Okay, so the question was how well Metaio can track words on a paper. Words don't track very well. To create a good image trackable, we need to have a gradient, and pictures work much better than anything like words or a very high contrast image.
Hi, where we can download the code, the SDK of Metaio?
So the question was, when can we download Metaio SDK? Well, it's currently available on our website at metaio.com. However, the newest version, it should be released during AWE this week.
Hi, can you talk at all about the new thermal recognition that you guys are working on?
Sure. So the question was about our new thermal recognition. So you might have seen some news articles about we're developing technology where a device with a thermal camera can be pointed at a generic surface, and it can recognize touches on that surface by the heat signature left behind and create basically a touch screen out of anything. Currently, it's a research project, and we don't have anything to announce about when it's going to be released as part of the SDK, but we'll definitely keep you updated.
Could the thermal imaging address the tracking of the black vehicle in some way?
The question was, could the thermal imaging help with the issue of tracking the black vehicle? I don't know. It possibly could. That's a good question. We'd have to look into that.
Great speech. We're using Metaio ourselves. Just trying to drop a 3D character into a room. Just say it was a tour guide at a museum, but I'm trying to make that 3D character an actual video of someone rather than an animated character. Is that possible yet?
So in order to do that, you'd have to have a 3D model of that person. So you'd want to have basically a photorealistic 3D model. And that would depend not so much on our SDK as on the technology used to generate the 3D model. So, I mean, photorealistic 3D models are certainly possible with 3D modeling tools that are available today, and also new scanning types of of technology. But you do have to keep in mind the number of polygons that are required by a photorealistic 3D model will, depending on the device you're running it on, there's limitations to the number of polygons that can be rendered at a good frame rate. So there's kind of a trade-off there, the amount of realism with the performance on the device.
I actually work for Metaio. So in addition to that, you can also do keyframe videos. So it's not exactly a 3D model, but we have a tutorial online on how to do that. If you have a video of someone speaking, kind of green screening the background, cutting them out so that it looks like that the person is just there.
I think we spoke on the phone.
Probably.
Yeah, so if you don't need an actual 3D model, but you just want a video, that's totally possible.
That's just 2D though.
Right.
Hi, were you here for Patrick's talk earlier? So he mentioned that for just the camera offset registration, it's close but not perfect yet. So when do you think that will be resolved?
We are releasing a new update to the calibration for the Epson glasses with this release this week, which resolves many of those issues, and we'll be continuing to improve it over time. So we'll keep evaluating it and make sure that it's accurate to being like real life. All right. Thank you.